Good morning, students. In today's lecture, we will talk about the chemical properties or chemical reactions of carbon and its compound. So basically, here there are five carbon chemical reactions. Number one is combustion, number second is oxidation, then number third reduction, then number fourth addition, and number fifth is substitution. So carbon and its compounds exhibits basically five types of reaction, and the reactions are again combustion, oxidation, reduction, addition, and substitution reaction. Now, number one, combustion. What is the meaning of combustion? Burning of any substance in presence of oxygen is called combustion. As a result of combustion reaction, energy is produced in the form of heat and light. That heat energy can be used for cooking purpose, or it can be used for any other purpose. So combustion is simply burning of any substance in presence of oxygen. If carbon is made to react with oxygen, means here we are talking about the combustion reaction of pure carbon. It is reacting with oxygen, it means it is exhibiting oxidation, or it is exhibiting combustion reaction. So carbon combines with oxygen, as a result of which it gets converted to carbon dioxide gas, and energy is liberated in the form of energy. So when purest form of carbon is taken, then we always get carbon dioxide. But if hydrocarbons are taken, compounds of carbon and hydrogen are called hydrocarbons. Then as a result of combustion reaction, hydrocarbons will be converted to carbon dioxide and water vapor with the release of energy in the form of heat and light. So here let us take methane, Mars gas. This is also called Mars gas, and this is the gas which is used as a fuel under the name CNG, compressed natural gas. So in presence of oxygen, it undergoes burning, as a result of which we obtain CO2 gas and water vapor with the release of energy. Carbon combines with O, forms CO2, H combines with O, forms H2. The reaction is not balanced, we have to balance the reaction. So for balancing, just check here, we are having 4 hydrogen. On the product side, we are having only 2 hydrogen. So for making 4, we have to multiply H2O by 2, giving you 4 hydrogen, 2 to the 4. Now what about the oxygen? 1 into 2, 2 oxygen, 2 into 1, 2 oxygen, 2 plus 2, 4 oxygen atoms are there. And here on the reactant side, we are having only 2 O atoms. So multiply O2 by 2 will give you 4 atoms of oxygen. Now, next, oxidation. What is oxidation? It is very simple. Addition of oxygen or removal of hydrogen is called oxidation reaction. Whenever a substance is exhibiting oxidation reaction, it means either O is removed, either O is added or H is removed. Oxygen is added or H is removed. This reaction takes place in presence of oxidizing agents. What are oxidizing agents? The substances which are responsible for oxidation reaction are called oxidizing agents. Like we can use here, we can use acidic KMnO4, which is called potassium permanganate. It can be used as an oxidizing agent. We can also use acidic K2Cl2O7, potassium dichromate. It can be used as an oxidizing agent. We can use alkaline KMnO4, medium is changed, or we can use alkaline K2Cl2O7. There are many oxidizing agents, but here I have written only two because these are important. This substance can be used as an oxidizing agent. This substance will carry out oxidation of other substance. Like for example, if I am using ethanol, that is the second member of alcohol series, then in presence of acidic KMnO4, alcohol will undergo oxidation reaction. As a result of oxidation reaction, the CH2OH unit will be converted to C double bond to OH, and as a result of which we will obtain CH3 C double bond to OH, which is called ethanoic acid. Just see the change. CH2OH unit is converted to C double bond to OH unit. Means what we have done? We have removed hydrogen and we have added oxygen. One O is more in carboxylic acid when it is compared with the alcohol group. It means we have removed hydrogen and we have added oxygen. So this removal of H and addition of O takes place in presence of acidic KMnO4. So conversion of ethanol to ethanoic acid in presence of acidic KMnO4 is a type of oxidation reaction, and acidic KMnO4 here act as an oxidizing agent. Then we have reduction. Reduction is opposite to oxidation. In reduction reaction, H atoms are added and O atoms are removed. We need reducing agents to carry out reduction reaction, and as a reducing agent we can use LiAlH4, which is called lithium aluminum hydride, or we can use NaBH4, which is called sodium borohydride. Now, if CH3COOH, which is called ethanoic acid, is taken with reducing agent lithium aluminum hydride, then ethanoic acid undergoes reduction, as a result of which COOH unit gets converted to CH3 CH2OH, and now we obtain ethanol. See the change. COOH unit gets converted to CH2OH unit. What is the difference? One O is less and two H are more. It means we have removed oxygen and we have added hydrogen. So conversion of ethanoic acid to ethanol in presence of lithium aluminum hydride is a type of reduction reaction, and lithium aluminum hydride here works as a reducing agent. Then comes the addition reaction. What are addition reactions? Addition reactions are those reactions in which two reactants react to form a single product. And remember, in organic part, addition reactions are the most important reactions of unsaturated hydrocarbons. Unsaturated hydrocarbons exhibits addition reaction, as a result of which these are converted to saturated hydrocarbon, and here we can use what? We can use ethene, that is CH2 double bond CH2 in presence of H2 gas, and as a catalyst we are using metal nickel, or it can be platinum, or it can be palladium. So H2 gas is used in presence of nickel, platinum or palladium. As a unsaturated hydrocarbon, we have taken ethene. Now what will happen? They will combine with each other. One H will be added on this carbon, one H will be added on this carbon, as a result of which double bond will be converted to single bond, and ethene gets converted to ethane. Two reactants react together to form a single product. Unsaturated hydrocarbons gets converted to saturated hydrocarbon by addition reaction. In this reaction, as we are adding hydrogen, so this reaction is also called hydrogenation reaction. As we are adding hydrogen, that's why this addition reaction is also called hydrogenation reaction. And at last, we have substitution reaction. You know the definition. When a more reactive group displaces a less reactive group from a compound, the reaction is called substitution reaction. Remember, substitution reactions are the important reactions for saturated compounds. All saturated compounds will exhibit substitution reaction, where one atom or group of atoms will be replaced by another atom or another group of atoms. Like if we use CH4, that is methane, in presence of chlorine and sunlight, the reaction requires the exposure to sunlight. The reaction takes place in presence of sunlight. Now what happens? One Cl from here will replace one H from here. So this H with another Cl will combine together to form HCl. And Cl first, on replacing H from here, will gives you CH3Cl. So one Cl atom has replaced one hydrogen atom for methane, as a result of which methane is converted to chloromethane. So this is an example of substitution reaction, but is also called displacement reaction. In the same manner, if we use CH3Cl with aqueous potassium hydroxide. Potassium hydroxide is a white color solid. When dissolved in water, it will give you solution of potassium hydroxide. Now what will happen? This OH from here will displace Cl from CH3Cl. As a result of which we will obtain CH3OH, and side product formed will be KCl. So here one group is substituting another group, as a result of which we are getting the product. So this is all about the chemical properties or chemical reaction of carbon and its compound. Thank you and have a nice day.